Okay, guys, we discussed about statistical quality control. So, in this particular video, we'll be checking about control charts. Just introduction about control charts only. We are not going to discuss about detail about X bar or R chart or other P chart, C chart or Q chart, what are U chart and all. Just what is control charts, what are the types of control charts, and how to choose the control charts. Only that kind of things will be discussing in this particular video. Okay, so objective of variable control chart is for what purpose we have the sense for quality improvement will be, of course, control charts will be useful for improving the quality and also to determine the process capability and also for decision in regard to product specification and for current decisions in regard to the production process and also for current decision in regard to recently produced item. So production process in the sense product also involved. So in order to make decisions, we will be using control charts. So that objective of the control charts uh, will give some data for us to improve the product quality or make a decision on the product and also production process. Not only product, if we are making product, this is good or bad. Not only we are going to make the decision on the product and also the process which makes that product also we need to ensure it is acceptable or not. So for that also that control chart will give some data. From that we can able to make our decision. So that is also one of the objective. And product specifications. So once we make the product, if it's features or functionality of the product are good or bad, so based on that only, that depends on the specification of the product. If you want to make the decision like a length wise or breadth wise, width wise, depth wise kind of thing, if you want to make a decision, for that also control charts will be useful and for improving the quality, quality and also for process capability, we will be using the control charts. That are all the objectives. Then in terms of data analysis or statistics, you will be having different charts or diagrams, pie charts, all the things. Histograms also one of the kind will be used mostly, but histogram do not give or take into account the changes with respect to time. In Instagram don't consider the time with okay, it won't consider. But control charts like X chart, P chart, X bar chart, S chart, NP chart, P chart will consider the time, which tell us when a process changes. Okay, suddenly this is the production. This is the production process, and average is goes. Suddenly, some variation is happening. So that particular location, when it is happening, we can able to come to know from the control charts. But in terms of histograms, we won't be able to get that. Then variable control charts, attributes control chart, two charts are there. So variable control charts will give numerical values can be obtained from the quality characteristics, but in terms of attributes, numerical value is not specified for the quality characteristics. In other words, it will be giving either defective or non-defective, conforming or non-conforming, like that will give in terms of attribute control chart. But in variable control charts, it will be giving variation in terms of number numerically, which represent the quality characteristics. Okay. So again, as I said, statistical quality control. Under that, you have statistical process control. This process control will have a charts, variable chart, and attribute charts. Under the variable chart, you have R chart and X bar chart. Sorry, under the variable, yes. Under the attribute chart, you will be having P chart and the C chart. One by one, we'll discuss about the each chart at the next video only. So in this video, just the basic concept of control charts will be studying. So, what chart, control chart should I use? You will be having lots of questions. Our industry people also will be having lots of questions on that. So, this flow will give clear idea about two versions of the same thing, two versions of charts also that this one or this one. Both are easy. Just I will explain with one also in the next also, which one comfortable for you guys. You can use that. So control chart either classified as a variable or attribute, as I said. In terms of variable, If you consider, you have a different number of charts in terms of variable, X bar and S chart, X bar and R chart. R means range chart, X bar in the mean chart, you can say, X chart or moving average chart, like that. So when we can able to choose this one, X bar comma S chart, or this one, in the sense, it depends on the number of sample. Okay, how many number of samples are you choosing? Based on the number of sample only, you are going to decide the particular chart. Okay, for example, if you have large number of sample, then you can go with the X bar and S chart. What is the large number? What is the amount, large number, in the sense 10 and above, more than 10 samples if you are taking, then you can go with the X bar and S chart. 10 and above means, sample size of 10 and above means, you can go with the X bar and S chart. But if the sample size is small comparatively, what is that? It is between 2 to 10. If it is between 2 to 10, sample size is between 2 to 10, in the sense, you can go with the X bar and R chart. You can go with the X bar and R chart. If sample size is only one, in the sense, you have to go with the X chart or moving average. So with this understanding, you have to go. Okay. So not much needed for X bar or R chart in detail. Just equations are there, but which chart to choose, it depends on the number of sample. More than 10 or more than 10, X bar and S. 2 to 10 or 2 to 10, in between 2 to 10, X bar and R. Then sample size is 1, the X chart and moving average type you have to use. That is considered variable. If it is attribute charts, you will be having again defective units or number of defects. Okay. Defective units, in the sense, one defect is there or multiple defects are there, like that only. Attributes, in the sense, defective units, one defective unit or multiple defects. Okay, in this way we can classify. So one defect, in the sense, what number of sample, how we consider the sample, whether constant sample or variable sample. If we consider the constant sample, the n number, the sample numbers are constant, from that we get one defect, in the sense, constant sample, in the sense, we have to go with the P or NP chart. If we are going with a variable sample and defective units, one defective unit is there, in the sense, we have to go with the P chart. But multiple defects are there, in the sense, either you have to go with C or U chart or U chart alone. When to go C or U? If the sample are constant, we have to go with C or U. If samples are variable, you have to go with P. In both the condition, P chart will be useful for variable, but one defect only. U chart is useful for variable samples when multiple defects are there. So you have to remember this chart. The same thing represented in another format. Select a control chart. How to select? Either it is variable or attribute, we have to first choose. If it is variable, if that data are being variable, then we have to think about the sample size. What is the sample size? Either n equal to 1 or n is between 2 to 10 or n greater than or equal to 10. So if equal to 1, in the sense, x are moving our average type, or between 2 to 10, in the sense, x or r chart, x bar and r chart, and greater than 10 or equal to 10, in the x bar and s chart. If the data is very attribute data, then you will be having the defects per unit. If the defects per unit is single, then you have to think about the sample size, whether it's a constant or variable. Or defects per unit is multiple, we have to consider the sample size either constant or variable. If it is constant, if multiple defects are there, if the sample size is constant, then you have to go with the C chart. If that samples are variable, from variable, sample size is variable, then you have to go with U chart. If single defects per unit is there, then constant sample means you have to go with the NP chart, or variable means you have to go with the P chart. Okay, so this understanding you should know. So if you remember that, mostly we can able to decide whether which control charts we are going to use. One is either data is variable or attribute, you have to know. Then if you decided variable in the sense number of sample size, you have to check whether less than equal to 1 or between 2 to 10 or greater than 10 or equal to 10. With that you can able to decide x bar or r, x bar or s or moving average. Then in terms of attribute charts, number of defects, if number of defects are single, then you have to go with the np or p chart. Under that, the sample which is constant sample np chart, variable sample p chart. Then another side, multiple defects per unit, if you are having, you have to go with either c or u chart. If samples are constant, then you have to go with the c. Samples are variable, in the sense you have to go with the u chart. So this understanding, if you have either this diagram or this diagram, if you are familiar, so mostly we can able to decide go with which chart we are going to use for our purpose. Then control chart techniques. Some of the techniques are there in terms of control chart. As the subgroup size increases, if we have subgroups in our samples, groups increases, the control limits become closer to the central value. Okay, if you are increasing number of samples and do some more subgroups and analyze in the sense that variation we can able to minimize. Okay, and we can go closer to the nominal value. But the subgroup creation will lead to increased cost for inspection. Okay, inspection cost will go. So you can't able to increase more number of subgroups. Optimization is needed, but we are not going to discuss about optimization here. But we need to choose properly, and if some sample needs to be destroyed, like destroyed in the sense destructive testing is needed on the sample, in the sense we have to go with a small subgroup size only. We can't go with the big, because everything will be destructive testing if you are doing. It is not feasible. Cost wise, it's not feasible for us. So we have to choose properly. Then how control chart setup decision. What are all the things we have to make a decision when we are before we are going for setting up any control chart. Some decision we need to take. So what are all the decision? We have to define which type of chart we are going to use. So as I discussed in this previous slide, based on this concept, you have to decide which type of chart are we going to use first. Then what are all the quality characteristics are we going to consider about the particular product? We should list out. Okay. The way we should sample should, how we have to select the sample. That sample should maximize the difference between the samples. Okay, maximize differences between samples. If you take multiple samples from different unit, that sample should possess maximized differences. Okay, inside the sample you have to find the maximized, but within the sample, in the sense you should have the minimum variations only. So between sample you should have a maximum difference. Within samples you will be having the minimum differences. That should be there in terms of selecting sample. Okay, may need a separate control chart for individually. For example, if you are considering about the operator, if you are considering about the machine, or depends on the vendors, if you are analyzing, in the sense you need separate control charts and analyze, then only you can able to get the better result. Then how to determine the sample size also very important. Generally, for example, 1,000 components, if you are taking 100, like 10 percentage, or are you taking 20 percentage, 30 percentage, 40 percentage, 50 percentage, like it's also very important. Cost wise, time wise, it's important. Okay, sometimes something goes wrong, even though you are taking 100 sample, that 100 sample is not representative of some faultiness, then selection of sample goes wrong. Sometimes that sample which you selected is not representative of the true manufacturing. It is giving all wrong. The measurements are giving quality is not good. Simply if you are rejecting whole that 100 components, like that 10 percentage, in the sense, of course balance 90 percent also will go out. But that 10 percentage which you selected may be not done properly, but rest of the 90 may be done good. But you selected sample by mistake. So sampling also has a techniques. It is very important. So determining sample size is very important. Okay, so you must consider about the cost of inspection or cost of testing, and also cost for shipping a non-conforming item like guarantee related products. If you are having, then you have to cost of shipping also important. Cost of providing sub-bar services also important when we decide control chart setups. Okay, before we are setting up any decision on control chart, we have to do this. Then frequency of sampling. Frequency will decrease when bringing the process in control. So how many number of samples are you? For example, 24 by 7 it is running. In the sense, how many times, how frequently you will be taking samples from the production process. Depends on how we are doing control over the process. If we do proper control over the process, the frequency of taking sample also can be reduced. Okay, we can take every day one or two only instead of every hour taking one. So it depends on how we are controlling. It's not come with the first day itself. By every day, regularly, if we are doing, then improving the quality, improving the process control, we can decrease the frequency of sampling. Okay, and what kind of instruments are we going to use for inspection and its accuracy, and how we are going to use also very very important to decide the or setting up the control chart. Design of data recording forms and software. What kind of data collection method are we using? Whether paper pen method or Excel or some other PDA devices or softwares are we going to use? We have to decide. So that also will make some impact on deciding the or setting up the control chart. Okay. So up to this, I'm winding up for this. So in this one, basics about control charts, how we can able to sorry, and why not we should not use Instagram. Instagram not accounting any time, but control charts will give time and will give when the process goes wrong. We can able to get and difference in terms of variable control chart and attribute control charts we have discussed in this one. So numerical values can be obtained for the quality characteristics in terms of variable control chart, but in attribute charts we won't be able to get the numerical value, but we will be getting a defective or non-defective or accepted not accepted like that on your quality characteristics in this attribute charts. So how it is classified, the process control charts, variable and attribute, under that R and X bar under the variable chart. In terms of attribute charts, P and C chart, how to decide the control charts, we discussed with this diagram. So based on either variable or attribute, based on sample size, and based on number of defects, whether multiple defects or single defect, you can choose a single defect in this way. Multiple defects in the sense we can go with this way for attribute. And in terms of variable, based on sample size n equal to 1 or between 2 to 10 or greater than or equal to 10, we can able to decide the X bar or R chart, X bar and S chart are moving average time. Okay. Then some of the techniques or some of the setup decisions we have discussed in this particular video. So I'm closing this recording. So next video probably some problems, numericals from X bar or R chart. Okay, we'll see. Okay, thank you.